Let's now talk about the idea of the odds of an event occurring. Odds and probabilities are very tightly related to each other. Now, the odds of an event is defined as the probability the event will occur divided by the probability it will not occur. Now, notation-wise, if we're dealing with empirical probabilities, we can say that this is p hat divided by 1 minus p hat. This is an empirical or observed odds. If we had the true probability of an event, we say that it's pi divided by 1 minus pi. Okay, the probability that you observe only one head when tossing 3 coins is what? Enumerate the sample space and figure it out. Well, we enumerated earlier, and if I recall correctly, we had 0 heads, 1 heads, 2 heads, and 3 heads. This was 1, 3, 3, and 1. So the probability to observe only one head, here's one, there's 3 ways out of 8. So the probability of one head equals 3 out of 8. Now I want to tie this in to the idea of an odds. What's the odds of observing only one head? Well, if the probability of one head equals 3 out of 8, then 1 minus the probability of one head must be 5 out of 8, correct? So the odds will be 3 over 8 divided by 5 over 8, which is 3 over 5. Now, the way you write it from here is kind of like up to you. There's a couple different representations. You can say that the odds is 3 to 5, which makes sense. That means that if we toss these 3 coins 8 times, 3 plus 5 is 8, that's the entire sample space, right? That's N of S. We would expect to see 3 of them where there is only one head observed, and 5 of those tosses we expect to see something else to happen. Well, if you divide 3 over 8, you get what? That's the same as 6 over 10, right? So that's 0.6. Agreed? This is the same as 0.6 to 1. 0.6 to 1, when you have a decimal leading off, something less than 1, those type of odds kind of tend to confuse people. But 0.6 to 1 is saying the exact same thing. If you toss these coins, 3 coins, for every 0.6 times you observe one head, you'd expect 1 time you observe something else. So that's really exactly what these odds are actually saying. Now, we can go in both directions. Given a probability, we calculate the odds like we just did, or given the odds, we can calculate the probability. Now, given the odds for a particular team winning a tournament is 3 to 5, what's the probability that they win? Well, this is kind of like this. It's kind of like the coin toss thing we just did. This is saying for every 3 times you expect them to win under these conditions, you expect them to lose 5 times. So the odds is 3 to 5. Well, there's 3 plus 5, right? There's 8. There's a total of 8 things there. So you go say the probability that they win is equal to 3 divided by 3 plus 5, and that's 3 over 8. What if you say, hey, there's a 20% chance of rain tomorrow? What's the odds of rain? A 20% chance of rain. What does that mean? Well, if the probability of rain is 0.20, I can represent 0.20 a couple ways. I'm going to write this as 2 over 10. Okay, that's a probability. That means the probability of not rain must be 8 out of 10. So 1 minus the probability of rain equals 8 out of 10. That means the odds are 2 to 8, or 1 to 4. Is that right? Yeah, that looks good. Okay, this is saying for every 2 times it rains under these conditions, I'd expect it to not rain 8 times. So I went from probabilities to an odds. And that's really all there is to it. I can go back and forth as I need to.